Now let's talk about limit, okay? So don't forget this word, okay? Whenever you have to evaluate the limit value, you have to start from by plugging in, okay? And do you know why we can find the limit value by plugging in? If your function is continuous at that point, your limit value will be same with your function value, okay? That's why we can plug in, okay? If it is not continuous or there is an empty hole, then you cannot get the like a real value by plugging in, which is indeterminate form or undefined. Is okay? That moment we're gonna do like another thing, okay? But anyway, like first starting point is always plugging in, okay? Let me plug in 1 in there. What is that? By plugging 1 squared minus 1 minus 2 over 1 plus 1. Oh, what is that? That is negative 2 over 2 and negative 1. That's it. So like for this problem, this is the answer. Done. Because your function is continuous at x equals 1. What happened? Again, whenever we have the evaluated limit, and we're going to start from by plugging in. We're going to plug in t equals 0. Then like for this problem, when you plug in t equals 0, what happened? Here we go. T equals 0, then your numerator will be square root 2 minus square root 2. Oh, 0 and 0. Dun, dun, dun. That is exactly indeterminate form. But do you remember, like if you have an indeterminate form with the square root, and I gave you one important technique, right? Which is we will multiply the conjugate of your numerator, okay? Here we go. So we will multiply here square root of 2 minus t and conjugate, which is plus, okay? And denominator, always same thing multiplied, okay? That's it, okay? So here we go. Let me rewrite this, guys, okay? And denominator, I'm not going to do anything, just like it right again, okay? T times with the parentheses 2 minus t plus, and do you know why I wrote this one first? Don't do anything, okay? Because we're going to do something else later, okay? So numerator, we're going to do like distribution, okay? But don't forget this guy, okay? A minus b times a plus b is equal to a squared minus b squared, okay? That's really simple algebra, okay? So what happened when you multiply these two? That will be 2 minus t squared minus square root 2 squared. Is it okay? So let me keep doing. Is equal to limit t goes to 0. Again, don't do anything but rewrite your denominator. I know it is really tempting to cancel out. No, I mean, it's really tempting to distribution, but don't do that. Just leave it like that. Okay? I will tell you why, okay? So numerator, like this guy square, which is 2 minus t without square root and minus 2. Then as you can see, easily can find this guy. It's gone, okay? Then one more time. Still, we didn't do anything for limit, okay? Just keep writing, okay? Negative t over t and square root of t, 2 minus t plus. There we go. This was the reason why I asked you to not do anything for your denominator, okay? Because like I wanted to cancel these guys, 0 factors, okay? That is the purpose of this whole technique, okay? It is equal to, but still you have to write the t, a limit, okay? Because we didn't do anything yet, but we just like simplify everything. Now, it is time to plug in t equals 0. When you plug in t equals 0, and there's no problem to evaluate this guy, right? Square root of 2 plus, which is negative 1 over 2 square root of 2, okay? That is the answer. Again, whenever you have to evaluate the limit, plugging in is the first step, okay? When you plug in h equals 0, look at that. 3 to the minus 1 minus 3 to the minus 1, which is 0 over 0. Which is indeterminate form, okay? So we cannot evaluate with this form. Then what are you going to do? For this case, we're going to use the common denominator, okay? Let me rewrite your problem without negative power, okay? Which is reciprocal form, okay? Here we go. Limit h goes to 0. It will be 1 over 3 plus h minus 1 over 3 over h, right? So like it's a little bit complicated, okay? It is compound fraction, but as I introduced before, and for this case, whenever you have this kind of situation, what we're gonna do is we're gonna push your denominator out, okay? Then this will be written by this way. just numerator and your denominator. Okay, we push that out, right? Does it make sense? Now look at this guy. In this parenthesis, we're gonna try to combine as one single fraction. Is that okay? So by using the common denominator. Okay, let me rewrite this guy. H goes to 0, 1 over 3 plus h minus 1/3. Let me keep the space because we have to multiply something. Okay, we will multiply 3 over 3 here and 3 plus h over 3 plus h here. Okay, then we're gonna have like same denominator. Okay, let me rewrite here. Your h still goes to 0, but we didn't do anything yet. Here we go. And first one, again, denominator, don't do any distribution. Okay, just leave like that. Okay, 3 times 3 plus h, and numerator 3 and minus 3h, and we have this guy and here. Okay, now we're gonna combine. Okay, but be careful, whenever you have negative sign in from fraction form, there is parenthesis. Okay, so here we go. H goes to 0, 1 common denominator now, and numerator 3 minus 3 and minus h now, 1 over h. Okay, you have to keep that in mind. Okay, it always happened. Okay, then that is equal to limit h goes to 0, negative h over 3 times 3 plus h and 1 over h. Okay, dun dun dun, it must happen. Okay, your zero factor must be cancelled out. We're almost there. It is equal to limit h goes to 0, negative 1 over 3 times. So at this moment, there's no problem to plugging in h equals 0. It is negative 1 over 3 times 3, which is 9. That is your limit value. Okay, what about this problem? As I told you, you have to be careful about like absolute value notation. Okay, here we go. What is the like definition of this guy? It is the distance from the origin. Okay, so like this can be written two types. Okay, x, if your x is positive or 0. Okay, but if your x is negative, then it must be minus x. Okay, but again, this minus x is not negative value. Because your x itself is negative, then negative times negative is positive. As you remember, with absolute value, you will have only positive number only. Okay, here we go. Now what about this problem? Let me rewrite my problem. Okay, x goes to negative 4 minus, and x plus 4 and x plus 4. I would like to talk about the sign of this guy. Does it make sense? Okay, look at that. This notation, x goes to negative 4 from left-hand side, which means negative 4 is here, then approaching from the left-hand side. Okay, so which means your x is less than negative 4. Okay, since your x is less than negative 4, less than negative 4 plus 4 is small negative number. Does it make sense? So we found this is negative number. Since we have like, negative inside of absolute value, you have to make it positive. How? By multiplying another negative. Okay, so your numerator without absolute value is negative x plus 4. Does it make sense? But at the beginning, like it was really tempting to cancel, right? But again, you can't because there is absolute value. Okay, you have to take care of absolute value first. Okay, so here we go. Now we can do that. X goes to negative 4 minus side, minus x plus 4. Since we do not have like any absolute value anymore, and now we can cancel these guys, and that is equal to negative 1 over 1. So your answer for this one is negative 1. What about this one? This is another type of problem, okay? So like again, same thing. Whenever you have to evaluate the limit, we will start from plugging in. Plug in negative 1 in there, then that is equal to negative 3 over 0. Dun, dun, dun. Like algebraically, it is undefined, okay? It is illegal, right? But for limit problem, we can write like this way because like your denominator 0 is not real 0, but your denominator is getting close to 0, but like not yet. Does it make sense? So, but like, but keep that in mind. In this case, your answer must be plus infinite or minus infinite. There's only two choices only, okay? But what about this case? Is there plus infinite or minus infinite as your answer? You don't know yet, right? That's why I'm here, okay? Look at your numerator. Like, what is the sign of numerator? -3 is negative number, right? But what about this 0? As I told you, in limit, like, 0 has a sign. 0 could be positive 0 or negative 0, okay? For this case, we have to come back to the, like this notation, okay? Here we go. X goes to -1 on the left-hand side, right? Which means -1 is here, and your x is approaching this way, which means x is less than -1, okay? When you plug in, any number which is less than -1 and close to -1, for example, -1.1, something like that, on your denominator, -1.1 plus 1 is small negative number. Does it make sense? Cannot be positive. So this 0 is negative. Whoa! I have like two negative over negative number, then your answer must be positive. So this is your answer. Okay, so this problem is different with the previous problem, okay? In the previous problem, your x approaches to the point, but this one, x goes to infinite or minus infinite, which is limit at infinite, okay? So for this one, I introduced the higher order method, right? So what was that? The strongest guy of your numerator and strongest guy of your denominator only. Is that okay? So this guy can be rewritten by higher order. Or I know there are lots of different ways to evaluate this one, but it's up to you. You can do whatever you want, okay? Minus x cubed, which is the both of your numerator, okay? And minus 5x cubed, both of denominator. Then since we have only this guy, we can cancel out these guys. Then the answer is -1 over -5, which is 1/5. That's it, okay? But if you want to since your numerator and denominator has the same degree, then you can just answer by the leading coefficient, okay? It doesn't matter, okay? But with higher order, we also can explain everything, okay? And this is useful for later purpose, okay? Okay, so as I told you, I like this kind of problem, okay? So, but for this problem, it's easy, right? What you have to know is only two things, okay? You have to know e to the infinite is infinite. Don't touch him, okay? But the other guy is 0. Since that is equal to 0, you can ignore about it, okay? So let me try to figure out which part is e to the minus infinite by plugging in x equal to infinite. Look at that. When you plug infinite, oh, there we go. This guy is e to the minus infinite, which is equal to 0. And same thing on your denominator. That's it. Since we know, when x goes to infinite, we know these two terms will be equal to 0, then we can ignore about it, okay? So without that one, we can rewrite your problem, okay? X goes to infinite, e to the x over 2 e to the x. So without 0 term, right? Then there's no problem to cancel these guys. Then your answer is 1/2, okay? So for the practice, if your x goes to minus infinite, then what is your answer? It is -2. You can figure that out, okay? Okay, it's getting crazier, right? I know. But since your log is continuous function, we can just take care the limit of your inside function first, okay? So here we go. So this guy can be written by ln of limit x goes to infinite of x over x squared minus 3x, okay? Evaluating this one is really easy, right? What is that? Your denominator is faster than numerator, and no matter what, equal to 0. So that is equal to ln 0. But wait a minute, we cannot write like this way, okay? But it is 0, but keep that in mind. This is limit, which means getting approach to 0. Then we can say 0 positive. Because x goes infinite, it is exactly 1 over x. Since x goes positive, it will be 0 plus, okay? Do you know why I wrote like this way? 0 is not in a domain of your log function, but 0 plus is in your domain, okay? So do you know the graph of the log function? This is log function. Then what happened? Your x value getting approach to 0 from the right hand side. Okay, there we go. Does it make sense? Then your point must be on the graph. Then it is going down like this way. What about your y component of this point? It's going down forever, which is minus infinite. Okay, so the answer is minus infinite. So let's talk about this three problem. Okay, so to talk about this three problem, you should know about the graph of arctangent. Okay, here we go. Arctangent graph looks like this way. And horizontal asymptote, which is pi over 2. And there's another one, negative pi over 2. And the graph of arctangent is like that, okay? Y is equal to arctangent of x. Is that clear? Okay? So like from this graph, we can easily find one important like a limit behavior, okay? Endpoint behavior, okay? What about this point? On this side, when x goes to infinite, arctangent of x equal to pi over 2, getting upwards to your upper bound, right? What about this guy? When x goes to minus infinite, arctangent of x is equal to minus pi over 2. That's it. If you know like this two, then you can take care of this guy, okay? Look at that. When x goes to infinite, e to the x goes to infinite, right? So that is equal to arctangent of infinite, which is equal to pi over 2, right? What about second one? When x goes to infinite, log function is also goes to infinite. Even it's a little bit slow, but like it definitely goes to infinite, okay? So again, like, you know, the direction is important, okay? Speed is not important, okay? Anyway, it goes to infinite, okay? So this guy is equal to arctangent of infinite, which is pi over 2 as well, okay? But what about k? Well, do you remember the behavior of log function? Here we go. Let's start from here, okay? Log function. Log 0 plus, okay? Do you remember this one? If you know the graph of log function, that's really simple. Okay? So when your x value is approaching to 0, then it goes down like this way, which is minus infinite. We know that is minus infinite. Okay? With this idea, your limit can be written by like this way. Arctangent of minus infinite, which is equal to minus pi over 2.